Hi everybody, this is Prakash and this is my friend Harish, and we are currently pursuing a final year Bachelor of Engineering in Electronics and Communication Engineering from VEL TECH, Anna University, Chennai. And currently we are going to present a topic on an efficient and integrated approach for the detection of exudates and blood vessels in the color fundus images, which is a final year project. Let's have a look on the project. One of the greatest challenges of today's current healthcare is the severe progression of diabetes. As we all know, diabetes is a disease which is caused due to the increase of glucose content. And this diabetic retinopathy is a disease that is associated with a long-standing diabetes. Say a person is suffering from diabetes for about 5 to 10 years, he is prone to this disease called diabetic retinopathy. Okay, let me give you a background of what is diabetes. As we all know, when the glucose content in the blood, when the glucose content that is present in the blood increases, the blood vessel walls are made up of proteins. So this glucose converts or which degenerates or denatures these proteins, and when these proteins get denatured, the first step is the occlusion of these lipids or fatty acids, which they form a bulge called microaneurysm. This is the first stage. Once the blood vessels get overbulged, what happens is it leaks out of those the blood vessels, which is called as exudates. So these exudates are the primary symptoms or one of the most frequent symptoms of diabetic retinopathy. Okay, now let us see as to how the doctors or the ophthalmologists are currently detecting these exudates, which are primary symptoms of diabetic retinopathy. Now we're going to talk about the current methods of detection of this disease called diabetic retinopathy. And last week we were able to visit this Vasan Eye Care and of course Agarwal Eye Hospital, wherein we were able to visualize the manual detection of these exudates, which are the primary symptoms of diabetic retinopathy. So what the ophthalmologists and the doctors do is they apply a certain chemical solution into the eyes of the patients, and they enlarge the pupils. This process is called pupil dilation, wherein the pupil is dilated. That is, it means it is enlarged in order to take a photograph. Or previously they were using an instrument called ophthalmoscope, in which they used to manually visualize or clearly see the inside structure of the retina, which then take a manual picture, draw a manual picture and then continue with their further process of screening and treating. But this process has got so many disadvantages, like it takes up it wastes up a time of one day. One complete day is being wasted, and secondly it is a manual process, and about only 3 to 4 patients can be screened per day. And thirdly, this chemical solution which is applied into the retina or into the internal part of the eye damages the patient's vision. Of course, there are so many disadvantages, like it costs a bit and etc. etc. Because of all these problems, we are moving into an automatic method or another advancement for detection and screening of diabetic retinopathy, wherein a fundus camera is a device which is used to take the photograph of the internal structure of the eye, and this fundus photograph or a fundus camera, which gives the output of a fundus image, is right now being used for the sake of the detection of exudates. But when we consider the current method of detection, the doctors, even after getting into an automatic detection, they are still following this method of pupil dilation, wherein they are dilating the pupil. When I asked the ophthalmologist for the reason why they are still dilating the pupil for taking a fundus photograph, the answer given by the ophthalmologist was, when we take a photograph without dilating the pupil, the exudates, which are the primary symptoms, and the other symptoms like microaneurysms and hemorrhages, etc., are not clearly visible in the fundus photograph. And so here comes the role of an engineer, an electronics and a communication engineer, who will apply the image processing techniques into the image taken by a photograph, taken by the ophthalmologist, apply all these images and make the exudates which are invisible to visible. So the main aim of an engineer is to make these exudates, hemorrhages and the other symptoms visible in a fundus photograph. So several techniques have been proposed in order to detect these exudates. Among those techniques, we have selected the most successful 4 algorithms which were able to detect these exudates successfully. Among those methods, The first one that was successful in detecting these exudates were region growing method. Region growing method was a very good method in which Akera et al. Was the person who framed this region growing method. In this region growing method, the selection of exudates was done by using a method wherein a proper seed point must be selected, and from then the exudates would be detected. But in this method, if the selection of seed points is not proper, or if the selection is improper, then it would result in poor detection of exudates. And secondly, we do have another method called K-means clustering, and this fuzzy C-means clustering, which belong to the same method of clustering family. But the main difficulty of this clustering method is determining the number of clusters to use. In this method, the image is first divided into many clusters, and then it's been acted upon each pixel separately, or each cluster separately. But this image processing technique has got a difficulty of determining the number of clusters. If we improperly determine number of clusters differently, it would result in poor detection of exudates again. And finally, we have got this mathematical morphology. It does not work on low contrast images, or it is sensitive to the contrast of the image. And these are the existing methods, and these are the disadvantages of the existing methods. And right now we are going to talk about the proposed method, or the method which we've been proposed for the detection of exudates. Let's have a look on it. So this is the proposed method wherein, but before I explain you about this proposed method, let me give you a short picture of what is a color fundus image. As I was talking about the color fundus image, this is a color fundus image. When we talk about the main parts of the color fundus image, this is an optic disc. Let me explain you about the characteristic of this optic disc. Optic disc is the brightest part that could be ever found in a color fundus image. And secondly, these are all the blood vessels which can be viewed with the naked eye, and this is fovea, and the center part of fovea is called as macula, and these are the this is the presence of exudates if they are present in a color fundus image. So in order to finally detect and extract these exudates, obviously what we got to do is we got to remove this optic disc and these blood vessels. Once we remove this optic disc and these blood vessels, we can finally accurately detect and extract these exudates. But in order to detect and in order to eliminate these other objects, first of all we gotta detect them clearly. So, but there have been so many types of algorithms that have been that have been proposed in order to detect and eliminate them. So right now let us take a look of what we present or what we propose in order to remove these things. Hitherto I have told you about the method of implementation, and right now let us have a glance, or let's look into how we're going to implement it. And let me hand it over to Mr. Harish, my friend, who's going to explain about the coding implementation.
The syntax image show is provided for displaying the selected RGB image. Finally, the title for the image is input image. And then RGB to grayscale conversion. The main intention for converting the RGB to grayscale image is to clear this determination of hard exudates in the now RGB to grayscale conversion. Firstly, we are considering the dimensions of an image. Normally, the RGB images has 3 dimensions, that is red, green, and blue. The syntax gray equal to RGB to gray syntax is used to convert the RGB image into the gray image. And then the syntax else gray equal to RGB image. If the input image itself has a grayscale image, then itself it considered as an input image, and then image will be displayed in the grayscale, and it will be provided as a grayscale image. Now let me show the output files. This is the output of input image you are provided, and this is the conversion image. This is the converted grayscale image, and then we are going for the intensity adjustment. As we know, the exudates have the different shapes and size and pixels. We are processing the intensity adjustment for differentiating the exudate pixels from the normal pixels of the selected image. And the syntax image intensity adjust image will display the adjusted intensity image, and image show will use it for displaying the adjusted image. And then we are processing for, and this is the output for the intensity adjusted image, and then we are going to process for the morphological operations, After adjusting the image intensity, the blood vessels appear as the darker regions in the whiter background. So to narrow them, we are going to process for the morphological operations. And the syntax sterile is a translate structuring element which will create a flat disc shaped structuring element in the image where 10 specifies a number of discs. The morphological image dilate is developed by the intensity adjustment image with the SE. As we already know, dilation is the addition of pixels into the image. And then further process for the blood vessel removing. For removing of blood vessels, we are proceeding for the erosion of image. Erosion of an image is nothing but deletion of the pixels, which will lead to the complete removal of blood vessels in the image. And this is the blood vessel removed output image.
Now let me continue with the circular fitting method. As I already told you, the optic disc is the brightest point, and in order to find out the brightest point, we're going to take the median of the maximum pixel values, and once we consider the maximum pixel values, we then draw a mask around the circle using this radius is 40, and then we take this mesh grid, MESHGRID, which is the syntax which we used, and then the formula for drawing the mask is square root of x median whole square plus y median whole square. Okay, on applying this formula we draw a mask, and finally we go for, let me show you the output of the circular fitting method. Now, this is the output for the circular fitting method. And now let us draw the next step is the canny edge detection. The syntax for the canny edge detection is edge of gray, which is the image name, and the canny is the syntax name, and 0.09, which is the threshold value. After doing the canny edge detection, we go for the circular border detection, and finally we apply the circular border detection, and then we go for detecting of exudates. Once we find out the circular border, it is very easy to eliminate the circular border, and finally expanding the areas of exudates, and there may be presence of non-exudates areas like hemorrhages and these microaneurysms. We remove the non-exudates area, and finally we calculate the area. Once we calculate, the area calculation is done very easily, in the sense like we take the rows and columns, every row, and comparing, and if the pixel value is equal to 1, we increase the pixel value, and if it is 0, we keep it in common, and finally we get the area. Let me show the outputs. This is the output of the canny edge detection, and this is the output of the circular border detection, and this is the output of the circular border, and we're going to remove the circular border, and finally this is going to be the output of the circular border removed image, and finally this is the image of exudates. These are the exudates which ought to be photocoagulated using the laser in order to rectify or in order to treat for the disease called diabetic retinopathy. We have just calculated the area, which is 845 pixels. Thank you. Dear friends, we have come to the end of the presentation, and this is the time to conclude. And let me give a short review of what we're going to do in the future. The future scope of this project is we're going to find out the detection of microaneurysms and hemorrhages and etc. etc. We're going to find out. A diagnostic system. We call it a diagnostic system. We're going to design it, and we're going to give it to the public for the public service. Alright, and we've come to the end of the session, and this is the time to thank, and I would like to take this opportunity to thank the Almighty God who's given us, who's bestowed His blessings upon us. And I would also like to thank our parents and teachers, and a special thanks to Vijay Krishna Reddy and Sampath who have been helping us all through the work, and thank you all for watching. Thank you. God bless you all.